Good day everyone, good afternoon to all of you. I am Hansel Kumigran, one of the reporter for this afternoon. So I am going to report the topic under chapter 4, the frequency distribution and the graphic representation. And the topic that was assigned to me is all about the three graphs, which is the line graph, the pictograph, and the circle graph, or also known as a pie graph. So I'm going to discuss with you this afternoon these three graphs. So I know that you're all familiar with when it comes to talking about graphs. So let's start first for the line graph. So what is a line graph? So a line graph is a type of chart used to show information that changes over time. So we plot line graphs using several points connected by what? Connected by a straight line. So from the word itself, a line graph. So we should use a line, preferably a straight line, to connect the several points. So the line graph comprises of two axes. So this two axes is known as the x-axis and the y-axis. So the horizontal axis, so you see horizontal yung pahiga. It is known as the x-axis. And the vertical axis, which is yung patayo, is known as the y-axis. So that's the meaning of a line graph. So what is a line graph? So a line graph has its four essential parts. So what was these four essential parts? So first, we have the caption. Second, we have the stub. Third, we have the reasonable proportion of data, or the x-axis. And last but not the least, the number 4 part is the body of the line graph. So when we say the caption, so caption was placed or is placed below the graph representing the figure. Again, the graph and the caption is placed below the graph representing the figure. Second, the stub. So what is this stub? This stub is the data from the vertical line. So which is the y-axis. Diba? I mentioned earlier that the vertical line is our y-axis. So third, we have the reasonable proportion of data, which is the horizontal line, and under the horizontal line, this is the x-axis. And last is the body of the whole line graph. So what is the use of this graph? So why do we need to study this line graph? So as a future educator, so it is very useful for us, this line graph, because we are going to see the changes. I was mentioned earlier that this line graph is you were going to see the changes over time. So if we only have one variable in our graph, so we are not going to use a legend. But if our variable is more than one, we should use a legend to easily understand the labels of the graph. So I will going to show you example of a line graph. So before I'm going to represent the line graph from the reference book, from our reference book, I'm going to to show first a simple line graph for you to easily understand this graph or how to create this graph. So first, we should have the data that we are going um, to put in our graph, in our line graph. So at this point, I'm going to show you a short video clip on how to create a line graph or what's the part of a line graph.
I'm selling cookies to raise money for the soccer team. I've got one last box to sell. I'm keeping track of how many I've sold. I made a line graph. A line graph is a graph that uses points and lines to show data. You might use a pictograph or a bar graph to help you compare information about different groups. You might use a pie chart to compare parts of a whole. You use a line graph to track how a group or category changes over a period of time. What are the parts of a line graph? The title describes what is in the graph. My line graph tracks my cookie sales. An axis is a line that has numbers or categories and is used to create a graph. The x-axis is a horizontal line. That's the one that goes across. On my graph, it shows the days. The y-axis is a vertical line. That's the one that goes up and down. On my graph, it shows the number of boxes I sold. The points show how many boxes I sold on a specific day. How do you read a line graph? Graphs help us answer questions about data. How many boxes did I sell on Wednesday? To read a line graph, look at where the point lines up along the x-axis and y-axis. Look for the day of the week on the x-axis. Go up to the point and see where it lines up along the y-axis. I sold 7 boxes on Wednesday. How many did I sell on Thursday? I sold 5 boxes. When did I sell the most boxes? On Friday. You can tell easily because Friday's point is the highest on the line graph. Line graphs often track how something changes over time. They can help you see information in a different way. This shows how the size of the drama club has changed over the years. It shows the years on the x-axis and the number of members on the y-axis. Always pay attention to the scale on a graph. Not that kind of scale, Moby. The scale shows how numbers are organized on an axis. On this graph, the number starts at 15 and ends at 25. Graphs can use different scales. The numbers might go up by 5s or 10s, so it's important to look carefully. How many members did the club have in 2007? Look for the year on the x-axis. Then go up to the point and see where it lines up along the y-axis. There were 17 members. How many members were there in 2009? There were 20 members. Graphs can help you come up with ideas about the data. This graph shows that more and more students have joined the drama club over the years. The drama club has grown a lot since 2007. The school could use this information to give the club more money to put on plays. How can you make a line graph? Cool! You're selling lemonade to raise money for the soccer team? How much have you sold this week? You can use your chart to make a line graph. First, draw the x-axis and the y-axis and label each. Time is usually put on the x-axis. Add a title for your graph. Then choose a scale and figure out what numbers you want to put on the y-axis. Think about the smallest number and the highest number you will need to show. If the difference between them is a lot, you may want a scale that counts by fives, tens, or even hundreds. If the difference is small, you may want to choose a scale that counts by ones or twos. You need to show $2 and $20 on the same graph. You should probably use a scale that goes up by twos. Remember, you write a 0 in the place where the x-axis and y-axis meet. Do not write the 0 above it. Now find the points on your graph. On Monday, you earned $6. Look for Monday on the x-axis, and look for 6 on the y-axis. Then find a place where they meet and draw a point. On Tuesday, you earned $4. Look for Tuesday on the x-axis and 4 on the y-axis, and find where they meet. Keep going until you plot or draw all the points on your graph. Then use a ruler to draw straight lines that connect the points. Now you can use the graph to help you understand the data. You sold the least on Thursday, but on Friday you sold a lot more than the other days. Why do you think you sold so many more on that day? It looks like you are your best customer.
So that's it. So I hope you do understand the video that I was showed to you guys. So let's proceed now to the illustration coming from our reference book. So this is the illustration, the figure 4.4, which is line graph of frequency and midpoints of assessment of student learning to test taken by 50 teacher education students in a certain university in Metro Manila. So this is the illustration 1, the figure 4.4. So as you can see on the vertical line, you will see the y-axis, the frequency. So it starts from the number 0 to 9. And at the horizontal line, you will able to see the x-axis. It started from a number 48. So why it started from a number 48? So the number of items for the test taken by the 50 teachers is 100, total of 110. But the lowest and got the lowest score is 48. So it started from 48, number 48. So the difference between these numbers are 5. So 48 to 53 is 5. 53 to 58 is 5 also, and so on and so forth. So I will going to read the graph for you. So 48, two students. So this is number of two students, the frequency. So two students got the 48 score, and 53 students got the three students got the 53, and also 58. 3 students got 58, and 63, 4 students, and 6 students got 68, and 9 students got 73 points, and 6 students got 78 points. Then 5 students got the 83 points. Then 4 students got 88 points,
and 5 students got the 93 points, and we have 4 got the highest score, which is the 98 points. So from this line graph, you will able to see or evaluate so how many students got the lowest score and how many students got the highest score or the perfect score, maybe if meron, diba? So as a future educator, this will truly help us to see the performance of our students, if they pass the exam or not. So for example, you will see that there are more students who got the lowest score. So as a teacher, you will going to see now or to evaluate now what's the matter or what's the reason behind having getting a lowest or a lowest score. Many of those of your students got the lowest score. So as a teacher, you're going now to apply or find some new strategies or techniques on how to develop more your teaching styles for your students to um, learn from you more, and so that um, they'll able to pass your examination by the next quarter.
So now let's proceed to my next topic. So we have the cumulative frequency, the lesser than, and the greater than. So first, I'm going to um, discuss about the frequency. So a frequency polygon is a line graph. So the points are often not connected with a smooth line, but with straight line segments. And frequency polygons are used to show the changes over time. So I mentioned this earlier, the purpose also of the line graph is to show the changes over time. So the cumulative frequency. So what is this cumulative frequency? It is the frequency of the first class interval added to the frequency of the second class, and this sum is added to the third class, and so on. So what's this first class interval and second class and so on? So example, so the size of the class interval for the first class is 30 to 21. So it is equals to 9, their difference. So similarly, the size of the class interval for the second class is 40 to 31. Still, their difference is 9. So later on, I'm going to show you an illustration for you to understand well what I am saying right now. So a table that displays the cumulative frequencies that are distributed over various classes is called frequencies. That are distributed over various classes is called a cumulative frequency distribution or cumulative frequency table. So we have two types of cumulative frequency. So what was these two types? The lesser than type and the greater than type. So now I'm going to ask you, so how to get the less than cumulative frequency and greater than cumulative frequency? So I know that you don't know it because that's my job to explain to you how to get this two, the lesser than and the greater than. So I'm going to share to you the steps on how to
create also the line graph of cumulative frequency lesser than and cumulative frequency greater than. So before I am going to use the illustration from the reference book, I am going to show first an example or a simple example of a line graph of cumulative frequency lesser than and greater than. So I will provide a small data, small information for you to easily understand, because the example from the reference book composed of um, 5 and more informations or data, so it's hard for you to analyze it. So I'm going to present first a example not coming from the reference book, but later on I will present the illustration coming from our reference book. So please be guided. We are going to graph the two O-gives for the following frequency distribution of the weekly wages of the given number of workers. So this is the data that we are going to apply in a graph in our cumulative frequency lesser than and greater than. So for the weekly wages, we have 0 to 20, 20 to 40, 40 to 60, and 60 to 80. So as you can see, their difference is 20. And the number of workers for 0 to 20 is 4, and 20 to 45, and 40 to 60 is 6 number of workers, and 60 to 80 is 3 number of workers. So to get the cumulative frequency less than, so again the instruction is to add. So add first the first class to the second class. So 4 plus 5 is equals to 9, and 9 plus 6 is equals to 15. 15 plus 3 is equals to 18. So that's for our cumulative frequency less than. And for the cumulative frequency greater than or more than, so let's start first at the total of the frequency. So we have 18. 18, so 18 minus 4, we have 14. And 14 minus 5, we have 9 equals to 9. And 9 minus 6 is 3. So this is our cumulative frequency for greater than. So let's apply this one into a line graph. So as you can see on the vertical line, we have the number of workers. So the number starts from the 0 to 18. And then the weekly wages started from 0 to 80. So let's apply this data into a line graph. So for a less than curve or ogive, mark the upper limits of class intervals on the x-axis and take the less than type cumulative frequencies on the y-axis. So for plotting less than type curve points, so 20 is against 4, 40 is against 9, 60 is against 15, and 80 is against 18 are plotted on the graph, and these are joined by freehand to obtain the less than ogive. So for the greater than curve or ogive, mark the lower limits of class intervals on the x-axis and take the greater than type cumulative frequencies on the y-axis. So for plotting greater than type curve points, so 0 is against 18, so 20 is against 14, 40 is against 9, and 60 is against 3. So are plotted on the graph, and these are joined also by freehand to obtain the greater than type ogive. So a perpendicular line on the x-axis is drawn from the point of intersection of these curves. So this perpendicular line meets the x-axis at a certain point. So this determines the median. So here the median is 40. So the median of the given data could also be found from cumulative graphs. So as you can see, 40 is existing in our cumulative graphs. So on drawing both the curves on the same graph, the point at which they intersect, the corresponding value on the x-axis represents the median of the given dataset. As you can see, it was labeled already. So the less than cumulative frequency curve is from the upper limits to here x-axis upper limit to y-axis. Then the greater than is from the lower limit x-axis to the y-axis. So when we say the lower limit, the numbers from the left side, like for example 0 to 20. So the lower limit here is the 0 and the upper is 20. So for 20 to 40, same, 20 for the lower and 40 for the higher or upper limit. So I hope that you understand already this cumulative frequency, lesser than and greater than. So let's proceed now to the illustration coming from our reference book. So this is the illustration, the figure 4.4, which is line graph of frequency and midpoints of assessment of student learning to test taken by 50 teacher education students in a certain university in Metro Manila. So as you can see on the illustration 2, the figure 4.5 line graph of cumulative frequency lesser than and greater than of assessment of student learning to test taken by 50 teacher education students in a certain state university in Metro Manila based on table 4.4 data. So in y-axis, you will going to see the number of teacher education students who take the test. So at the horizontal line, the x-axis, we will going to see the scores of the teachers who take the test. So as you can see, so lesser than cumulative frequency, in plotting cumulative frequency lesser than 50 upper class limit is plotted against 2. Cumulative frequency less than 55 against 5. And 60 against 8, and so on. So for greater than cumulative frequency, in plotting cumulative frequency greater than, 100 upper class limit is plotted against 3. 95 against 8, 90 against 12, and so on. So I hope that you understand this cumulative frequency lesser than and greater than. So what's the point of getting cumulative frequency lesser than and greater than? So the purpose of cumulative frequency distribution are as follows. First, And the purpose is to find the number of observations or proportion or percentage of observations below or more than a certain value and in between two given values. So that's the main point of getting this two types of cumulative frequency. So I hope that you understand now on how to get the cumulative frequency lesser than and greater than. So I hope that this our discussion for this afternoon will retain to you guys, because this is very useful for us, the future educators. Sooner or later, diba? We're going to use this in our field of profession. So for the illustration number 3, I will not going to explain it more further, no. This represents a line graph having a two variable, which is the milk, fish, bones, and the pork. So when we are going to use a two variable, we should going to provide a legend. So don't forget that. Take note of that. So at the y-axis, at the vertical line, this is the percent given of the service, the percentage. And under the x-axis, this is the quality attributes. For example, color, odor, flavor, texture, general. So again, you're going to put a points, preferably kung ilang rating yung ibinigay sa ganun na quality attributes. So, same pa rin yan. The difference only is we have two variables for the illustration 3. So let's proceed now to our next graph, which is the pictograph. So what's this pictograph? A pictograph is another kind of graph which uses pictures or symbols to represent information. So again, in pictograph, we are going to use pictures or symbols. So for illustration purposes, consider figure 4.7 on the sales of milkfish bones and pork luncheon meat for the months of January to March. So we have here illustration number 1 for pictograph. So in illustration 1 for pictograph, the symbol that was being used here is the peso sign. So each peso sign stands for 20 per can. So for January, we have for milkfish bones, we have 16 peso sign, and for pork we have 14 peso sign. And for month of February, for milkfish bones we have 15. For pork we have 8. And for the month of March, milkfish bones we have 16, and for pork we have 6. So this will be multiplied on to the 20, because each peso sign stands for 20 pesos per can. So for month of January, for milkfish bones we have 340, and for pork we have 280 pesos. And for February, for milkfish bones, we have 300. And for pork, we have 160. And for March, for milkfish bones, we have 320. And for pork, we have 120. So milkfish bones total for the month of January, February, and March is 960. And for pork, we have 560. So for pictograph, This is a very understandable graph or easy to explain. So I will not explain so deeply because I know that in just seeing the illustration you will get to understand. So let's proceed to my last topic, which is the circle graph. So a circle graph or pie graph is a way of representing data in circular form. So the data divide the circle into parts and are represented in percent or actual figures. So the total of the whole circle is 100% or the total of whole figures. So if there are two or more variables in a study, only one set of variable is represented one at a time. So we have two variables, the milkfish bones and the pork. So let's have illustration number 1 for the milkfish bones luncheon meat. So the actual figures and percentage was being put here on our first illustration of the circle graph. And for the illustration number 2, we have the illustration for the pork luncheon meat. It is presented also here the actual figures and the percentage. Hello everybody. Thank you so much for listening my report. I hope that you understand my report well, and I hope that it will instill in your minds because it is useful for us as future educators. I hope that you are all safe and continue to soar high, and God bless us all.